Hey everybody, sorry I can't be there with you this week, but I figure we can still move on. First of all, we're going to be starting on page 12. It's the 7-4 lesson, Properties of Similar Triangles. My document shifted a little bit, but that's okay. If you had trouble with the 7-2, 7-3 practice, I went over some of it with first period, but I know my 8th period class, we didn't have class on Thursday because of the go home early. But I will be putting up a video later on walking you through some of these. So if you do have questions, check that out. Okay, so I would, if I were you, I'd pause this video and give the warm-up questions a try, or you can go ahead and work on them with me now. All right, so it says to write a similarity statement for the two triangles, and then it wants us to find CD, which is marked here. The easiest way to work with triangles that overlap like this is to sometimes pull them apart. So first of all, there's 3 ways to prove that two triangles are similar, which is different from congruent. Similar, remember, means same shape, but not necessarily the same size. So you can do that with angle-angle similarity, which is the most common. Side, side, side. So if the 3 sides are not the same, but they are proportional, and side, angle, side. All right, so let's take a look. Right now I can see that they both have a right angle, and then they both have a shared angle A. So they're similar by angle-angle similarity. So my similarity statement, let's start with the smaller triangle. I'm going to go in alphabetical order. It doesn't matter what you start with. So triangle A, B, E. Is similar to, now when you're doing the second triangle, you want to match congruent angles. So A matches itself, so A. Angle B's are right angles, so that would be angle C in the big triangle, and then E and D are the same. All right, so there's your similarity statement right there. Now, if we want to find the missing sides, like I said, sometimes it's helpful to pull them apart. So on our small triangle, we have 5 and 9, and on our larger triangle, we have X, and then if we look at the whole side AC, that's 12. So when we go to set up our proportion, X matches 5, and that would be equal to, since I started with X over here, I got to start with 12 over 9. Cross multiply, 9X equals 60, and if you divide that, 60 divided by 9 is 6.6 repeating, which is the same as 6 2/3. You could also just leave it as 6.6 repeating, 6.7. Sometimes it'll say to round. Just follow the directions. Okay, so today we're going to talk about the triangle proportionality theorem. Basically, if you have 2 triangles, you got this tiny triangle overlapping this larger triangle, kind of like what we have here. If these are parallel, okay, and then it divides those sides proportionally. So if we look, the small side over the large side is the same as the small side over the larger side here. So let's give that a try. It wants us to find US. Since these are parallel, the small side over X is equal to the small side, well, I guess it wouldn't be the small side, over 4. So basically, this angle to here over the rest of the section is the same as that same angle to here over the rest of that section. And then again, you just cross multiply. Once you get things set up properly, it's just cross multiplying each time, so it's pretty easy. From there, if you don't get it set up right, that's when you run into a problem. Okay, 56, and then divide by 10, X equals 5.6. Okay, so the same thing over here, find Pn. All right, so it doesn't matter how you set it up. they're proportional. So because these are parallel, this small chunk over x is proportional or equal to 2 over 5, the smaller side over 5. And if you did x over 3 equals 5 over 2, you'd get the same thing. All right, so we'll cross multiply. 2x equals 15 divided by 2. X equals 7.5. All right. Whoops. Again, this shifted a little bit, so if yours is not on the same page as this, that's okay. All right, it says to verify that they're parallel. So rather than us telling that it's parallel, we need to check to see if they're proportional. So we'll set up the same fraction. So starting at A, 10 over 15 would have to equal 8 over 12. Now you could simplify both ratios, or another quick way to do it is you could just cross multiply. 10 times 12 is 120. 8 times 15 is 120 also. If you're not sure, double check your calculator. So yes, they are parallel. Now, another thing you could have done is just simplify to see the similarity ratio. 10 divided by 15, and then hit math, enter, enter. They both simplify to 2/3. What's going on there? To 2/3. So that would work as well. So you could either show the cross products are the same or the similarity ratio is the same. All right, the last two questions on here are actually old Regents questions. So you can kind of get an idea of what to look for. A lot of times, everything that's above the picture or the diagram is already labeled in the diagram, and the question's usually right underneath. Sorry for the quality there. In the diagram of triangle ADC below, EB is parallel to DC. All right. It tells us AE is 9, ED is 5, and AB is 9.2. Like I said, labeled in the picture. What's the length of AC? Now we got to be careful here. It wants this whole thing. Now there's a couple ways you can go about it. You could call BCX and set up your proportion and then add it to 9.2. Or we could do what we did in the very first problem. Let me go back to that, the warm-up. You could, instead of saying, 3 over 9, you could say 3 over the whole thing or 9 over the whole thing. So because those are proportional, we could say, since you're looking for the whole thing, we could set up our proportion as part over whole. Totally up to you how you want to do it. All right, because basically you're looking at two similar triangles where the shortest side would be 9 and 9.2, and then for the bigger triangle, this would be 14, and you're looking for x. Okay, so it's totally up to you how you want to set it up. I think it's easier to go this route, but you could say, 9 over 5 equals 9.2 over x, and then once you get x, add it to 9.2 to get the whole thing. But I'm going to go this route, because if the parts are proportionate, so are the whole. So 9 over 14. So what I'm doing is this side over the whole side of the big triangle equals 9.2 over x. So we get 9x equals 9.2 times 14, 128.8. My gosh, what's going on with my pen here? And then divide by 9. All right, nearest tenth. So x equals approximately 14.31, so 14.3. Now, the alternate way to do it, let me just show you quick. If you would have done what we were just doing with the parallel, you could have done 9 over 5 equals 9.2 over x. Cross multiply. Let's do this quick. This is an alternate method. It's the thing with geometry. There's a lot of times you can do it in more than one way. So we get 46 divided by 9, 5.1. And then again, since it's looking for AC, you would have to do 5.1 plus the 9.2, which is also going to give you 14.3. So you've got a couple options there. Okay? All right, last example like this. To find the distance across a pond from point B to C, a surveyor drew the diagram below. The measurements made, sorry, my dog is making noises, are indicated on his diagram. Okay, so got some information there. Use the surveyor's information to determine and state the distance from point B to C. So we're just looking for this. It's just like the warm-up question. All right, so again, we could pull those apart if you want, or we could look at just each side. Again, I think it's easier to pull them apart. So here's my smaller triangle. This is 120. This is 230. And then for the larger triangle, what we're looking for across the pond is x. But right here, you want to add those together for the whole length. 230 plus 85, 315. I personally like to do it this way because then you can easily look and say, okay, 120 matches x, 230 matches the 315. So we'll set up a proportion. 120 over its match equals 230 over the 315, its match. And we'll cross multiply. 230x equals 315 times 120. 37,800, and then divide both sides by 230. So the distance across the pond, or the length of BC, to the nearest yard, which should be the nearest whole number, 164.3, so 164 yards. So a lot of times on the Regents, there's a lot of word problems, but don't let that fool you. Just look at the diagram, label, and you'll see that it's a more basic problem. The last thing I want to talk to you about is the triangle bisector theorem. So basically, if the angle's bisected, so both parts of those angles are the same, it sets up a proportion with the two sides. So what happens is BD over DC is equal to AB over AC. So kind of like what we were doing. The side opposite the angle over the other side opposite the angle is the same as the side next to the angle. So as you can see, we have an angle bisector. So I'm going to set it up. I'll say x plus 5 is across from it over the side that's across from the angle in the other triangle equals, since I started with x plus 5 in this triangle, 40 over 32. Now remember, when you go to cross multiply this time, to distribute. So 40x minus 40 times negative 2, negative 80, equals 32x plus 32 times 5, 160. A little bit of an equation to solve there. Remember, get your x's together first. I'm going to move that 32x over. Since it's positive, we'll subtract it. Makes it disappear here, and over here we get 8x minus 80 equals 160. Add 80. I don't know what's up with my pen. I apologize. 8x equals 240, and then divide by 8. So again, we did 160 plus 80 divided by 8. 30. Make sure you answer the question, though. It didn't ask a question. If you were looking for x, it's 30. If you wanted to find a particular side, you just substitute in. Okay, your practice begins at the bottom of the page. So, again, these two, just set up your proportions and go. This actually goes on the next page. I think it's right on your packet. Verify, so show that they're proportional. And there's an example of each one in your notes. These are showing that they're parallel, so you can find these pretty easy by setting up your proportions. If it helps, pull the figure apart into two triangles, and then give the questions on the next. I know some of them are circled. Ignore that fact. So get those finished through page 16, and tomorrow we'll do some more practice. If you have questions, stop by the math lab or shoot me an email. All right, have a great day, everybody. And again, watch for homework help videos. I'll be posting those at some point tomorrow. Oh, time to go.